So if you unzip your package, you should see a folder just like this in a directory layout. And one of those folders will be the quick start. And what the quick start is in Hoops Communicator, if you're unfamiliar, it's just a sample implementation of all the different components of Hoops Communicator, such as the server, the web viewer, and converter, all kind of bundled together and pre-set up for you to just use it right out of the box. And so a lot of the training today is just going to be using or piggybacking on the back end of this server and quick start setup. So if you go ahead and open the quick start, you should see, if the quick start, you should see a start server script in there. I'll go ahead and start that. I'm going to start that actually in VS Code right down here. So if I just run start server, you can see that that spins up a instance of the Hoops Communicator server. And if you're unfamiliar with what the server does, it basically just manages your data on the back end and streams that data down into the client. And we're going to be working mainly on the client. So I'm not going to focus too much on the back end, but feel free to send any questions in after the fact, and we can clear up anything about the server back end aspect of it. So now that we have our server running, just to verify that you can in fact access or Communicator is up and running, I like to open this index.html file, which is within the quick start directory, and then just click on one of these models just to make sure that it comes up, you're able to interact with it. If everything looks good there, then you know your Communicator instance is working just fine. We'll actually close that for a second and talk about just what operators are. So actually, let's back up a little bit. When you do open this model, there's a lot of web viewer creation and things like that going on. So let's just quickly go over what it's doing, because that's going to be the basis of where we're starting our exercises today. So what I'm actually going to ask you to do is within web viewer and source, go ahead and copy this Hoops web viewer sample.html. And this is the document we're going to be working with. So again, that's from the root directory of Communicator, web viewer, source, Hoops web viewer sample.html. I'm just going to take that and I am going to just paste it over into my quick start folder. And then I will rename it as operator training. So this is the exact same file that is being served with Hoops Web Viewer. We just renamed it and we'll request it up here in our local host URL. So you can see I'm requesting operator training.html with the micro engine model. It's the exact same path we had if you clicked on that micro engine model from the index.html. So maybe I'll pause here for a second just to make sure everyone's got a working version of this HTML file. And while you're trying to get it set up, I'll kind of walk through exactly what's going on in here. So you can see the code's pretty, at least the JavaScript is pretty concise here. All we're doing is when the window loads, we're creating a new viewer. And you can take a peek into these functions. This is coming from the sample.js file up here. Just spinning up a new viewer, getting a handle to that viewer, setting up a resize function. This is always good practice to do, just so if you have any resizings of your windows, the Hoops Communicator canvas knows how to adjust, and that way your, say, mouse actions aren't going to be displaced or anything like that. So always a good idea to resize your canvas. Here we're just setting up some UI elements. So we do ship a sample default set of UI elements, such as the toolbar and model browser. We're just leveraging that stuff right here, and that's coming in from the, where is that? WebViewer UI.js script. So these are all provided within this source directory over here. You're welcome to use this in your application. We encourage you to change it make it your own, fit it with the style of what your downstream application will be. But we're just using the out-of-the-box UI here, and that's all we're doing with these lines. And then we're just starting up the viewer. And we're requesting the model up in the URL here, and that's how we're getting this micro engine here. So it's very simple code here, just starting up a viewer, establishing that WebSocket connection with the server. So operators. What is an operator? An operator is just an object that allows you to kind of hook into the event loop of the browser and perform interactions with your 3D model. So it's almost very similar to something like setting an event listener on, say, a DOM element. Say you had a div and you were going to say on mouse click and then give a callback function. Operators are basically the exact same thing. It's just a mechanism within Hoops Communicator to help make that whole process easier for you. So it'll be listening to events such as mouse clicks or keyboard events, and then you can set up your own logic when Communicator recognizes one of those events to fire and then do whatever behavior you're trying to have that do. And so out of the box, Hoops Communicator actually comes with many built-in operators. If you want to pull up your developer tools console, the reason I really like the quick start is because it allows me to quickly play with the API right within this developer tools console. If you look back at our code, you can see we're actually exposing this Hoops web viewer handle outside of any other code. And so while production code, you don't want to have this so no one can access your viewer. In the quick start here, it's great for just quickly prototyping. So you can see if I type in HWV, you can see that's our Hoops web viewer object, and you can see all the different objects that compose this Hoops web viewer object. And so there's a lot of different objects when you instantiate a Hoops web viewer that get composed alongside it, and you can access them through this Hoops web viewer. So the big ones, such as the model, you'll be interacting with the model a lot. So you do Hoops web viewer.model or the view. One of these is actually the operator manager. And so the operator manager is just responsible for maintaining a stack of operators that are active within Hoops Communicator. And we'll get into a more specific API usage of that. But I just wanted to first show, if you were to look at the operator manager, right out of the box with this quick start, you can take a look at that operator stack. So anything that's on the operator stack within Communicator is considered active in the browser. And so when I come over here and I'm clicking down and dragging left clicking and dragging my mouse like this, it's giving me that orbit operation. That's actually an operator within Hoops Communicator that's already been set up and made for your use. If I had no operators on my stack out of the box, if I tried to click over here or any sort of input, I'm not getting anything because none of those operators are there. So out of the box, when you're getting that navigation and that selection, all of those are pre-built operators that are set up in a very similar way to how we'll do a custom operator later. So those are all set up for your use and pushed to the operator stack. So let's take another look at that real quick. We can see that we have 1, 9, 21, 22, 23, 24, and 25. What do those mean? Those are just enumerations for the different operators we have. So one way you can quickly do that is just say communicator.operator ID. And so this will give you the enumeration of all those operators, built-in operators that we have. And so these are the operator IDs. You can see one, we have navigate. So that's what's giving you that ability to orbit, pan, zoom. And interestingly enough, 1 is actually just a combination of 2, 3, and 4, orbit, pan, and zoom. So we have 1 on the stack. You can also see we have 9, which is selection. That allows me to click and give me that selection. And then we have 21 through 25, which are sort of unique. 21 gives you access to doing cutting plane operations like so. 22 shows handles. So if you were to use the handles in here, that's also an operator. And then, whoops. Nav cube and axis triad, those are actually also interactive elements. So if I were to click on the z-axis, so those are also listening to, say, mouse clicks and things. So we implement them as operators as well. Same with the nav cube up here. If I were to click a corner, that'll change the camera orientation. And then floor plan I won't get into, but that's a new BIM specific functionality that will show you a 2D kind of floor plan of your building if you're navigating a building. Doesn't make sense with this model, but we have it on by default. So those are your default operators right out of the box. And that's what's giving you that interactivity on this quick start, or if you start up any Hoops web viewer. That's great. But how do I change things within the stack? Well, you saw earlier, I use the operator manager to clear the whole thing and take off all my operators. So the operator manager it's well named because it's going to manage your operators. And all it is managing a stack. And so if you look over at the operator manager documentation, you can see many of these methods that on the operator are just your standard kind of stack management operators, such as push, pop, peek. You can set a specific spot in the operator stack to change priorities of operators. And that's an important concept because, as I mentioned, everything that's in this operator stack is currently active. And so if you have a mouse click event, unless you handle that event within one operator, it will propagate through the whole stack. So I think what's at the end of the stack here has the top priority. So this operator, the floor plan operator, is going to see mouse click down first. If it doesn't handle it, it's going to move on to 24, 23, and move all the way down this operator stack unless a specific operator handles it. And what this allows you to do is have multiple operators active at the same time where you don't have to always be clicking between them. So if I come over here, sorry, I just want to clean this up. I can select, but I can also be moving at the same time. And so you can see the benefit of having multiple operators. However, it can be a disadvantage as well, and that's why you want to design your operators smartly so you're not getting conflicts between any active operators on the stack. And there's a few ways you can manage that. You can manage the operator stack by pulling things off and pushing them on, or you can do it within the actual operator code, as we will see later. So yeah, if I wanted to clean up the stack, or actually, yeah, let's start by saying Hoops web viewer operator manager dot clear. So as I showed before, that's going to remove everything from the operator stack. There's nothing in there now, and you'll get no interactivity there. I always need to do this. So there you saw I needed to refresh my page because I don't remember what was on my operator stack. Well, what's a quick way to quickly save your operators if you wanted to pull everything off the stack and then put it back on there? Well, we can just simply pop everything off the operator stack, saving it into an array. We could push whatever operator we wanted, and then when we were finished, we could just push all those saved operators back on. So if I said, I'll make an empty array here, and then we want to say we're going to make a loop for the number of operators. So we'll say get the number of operators on the stack right now. So oops, viewer operator manager, and there's a size. So if we look at that number of operators, you can see we have 7 operators on it. That corresponds to what we were seeing earlier. And then we can just make a quick little loop that pulls all of those operators off. So we'll just say let I equal 0, I is less than the number of operators, and plus I. Okay. And then within that loop, we can just say for each one, we're going to push the new operator from the stack that we're popping off of the stack into this array. So So yeah, for each element in the operator stack, go ahead and pop it off and push it into this ops array. So now if we look at the ops array, we can see we have all of those operators. Then I can go ahead and just clear my stack. So that gives me nothing. And then I could say just push a single operator. And so to put something onto the stack, you can either use the set command back on the operator manager over here. You can either use set, which you give it a specific number in the stack and it'll insert into that spot. Right now we have nothing on the stack, so we're just going to actually just push an operator and it'll have the number one priority. So I can push whatever operator I want. So using the operator manager, the push function, let's say I want to do a red line circle. So if you look over at the push, you can see push takes an operator ID. If you click on operator ID, you can see all the different operator handles that give you access to the operator object. So I'm just going to push a red line circle for now, just to demonstrate pushing an operator. So if I do that and I look at the operator manager, I can see I have one operator on my stack, 12. And if I right click and drag on my scene, I will be able to draw a circle. So this is another built-in operator. It's a markup operator. And I can draw circles on here. If I wanted to pop that off again, I can do the same thing, pop, nothing on there. And then let's say I wanted to put back all of the default operators I had from the start. You can see my ops operators array up here is actually the reverse order of the way they were stored to start with. And that's because I'm popping them off. So they actually get read in backwards unless I reverse that array. I want to keep the same order. So I'm just going to say ops.reverse. So that will just flip the array. So it's pushing them back onto the stack into the right order. And then we'll just say for each. And you can see it's completing up there. So for each of these handles in this operator array, I'm just going to push them back onto the stack. And then if we look at our operator manager again, you can see the operator stack has those operators back in its default order. And if I move over here, you can see I am now navigating, selecting all of that. So that's kind of the basic idea of pushing and popping operators from the operator stack. Keep in mind it is a stack and the event will propagate through. Most of these built-in operators are built so they don't have many conflicts with each other. A lot of the conflicts that you might run into will be when you're making your custom operators in addition to using one of these built-in operators at the same time. And we'll get into that when we talk about making a custom operator. Let's see. Jonathan, are there any questions or anything that have come in so far? I haven't seen. Oh, here we go, the chat.
Not yet. Seems,
okay.
How's everyone doing? Are you able to follow along with Chris okay?
All right.
Yeah, we got two checks, so that's great. Thanks guys. You're doing a good job there, Chris. I'm following along too. So far so good. Thanks.
All right. So at this point, I talked about these built-in operators. If you look down at this toolbar down here, I had mentioned we ship with a default UI that you're welcome to use. What this UI is really doing is just managing your operators for you. So we have our default operators out of the box, but if I come down here and I click on, say, this markup, and I click this circle, this is exactly what we just did. What just happened is we just pushed the red line circle onto the operator stack, and now that's taking priority over everything else. Let's take another look at the operator stack now that we've added that. So you can see we have 12 on there now. It removed 9, which was the selection operator, and pushed in 12 here. or it might have set it since it did it in the middle of this stack, but that's what's giving me the ability to draw these operators. If I were to click back on this mouse, it's just resetting that operator stack with different operators. Same with a lot of these walk operators or different navigation turntable operator. So these are all operators that I showed when, if you looked at communicator.operator ID. So all these different operators that I'm doing with the toolbar down here, pushing and popping, are just basically what are these built-in operators here. If you ever need to look at more about those operators, in the documentation here, the API reference, we have communicator.operator. All of these operators correspond to these operator objects. And each one of these operator objects implements this interface here. And so this interface has a lot of the classic callbacks that you might expect when listening for events, such as on mouse down, on mouse wheel, on key down, things like that. And so when you build your operators, and when we built them internally, we associated specific functionality within Hoop's communicator to these different events. And on that note, I think it's a great idea. We started shipping the operator code within the package now. So if you go to your package, actually I'll do this within VS Code. If you go to the package within Web Viewer, TypeScript, operators, we give you the source code for how we made all of these built-in operators. And so if I click on something like the selection operator here, there's some extra methods we added in for helping you with the API and convenience and setting up how you'd like it to behave. But at the core of it, it's setting up these event listeners, essentially, and waiting for an event to execute some sort of logic. So for example, with the selection operator, when I am over here in this desktop, let me reset this view. And I click here, it's listening for this on mouse up event. And so it gets that event and it's going through this motion. It's setting up a tolerance for, okay, what tolerance do I want when I make this picking operation? And then it's using the communicator API. So really these operators are just taking advantage of existing APIs, publicly facing APIs that you can invoke on these certain events. So this is a pick from point operation. What that's going to do is fire an array into the scene where I click on that position and find the best candidate node to return to me. And usually that's going to be the closest one. So if I click here, that's the closest to me in the screen, it'll return that. And it's just taking that selection, performing some various checks to see what's set up in there, and then adding this element to the selection set. So if you're ever curious about how a certain built-in operator works, say you're designing your own operator that it's a little bit different but has some of the same functionality, looking over into these this operator TypeScript source code is very valuable. It's also just valuable to read through and get some inspiration. You know, when you're thinking of what can I do with custom operators, what can I make? Sometimes just reading through some of this source code is like, oh, I didn't know I could do that. And then you can take those various ideas and aggregate them together into a cool little operator. And we'll see that when we start making the custom operator. So keep in mind that this operator code is available. And it's pretty useful to see how those operators are being set up. Okay, so now that we've kind of gone over built-in operators, let's talk about making your own operators. So to do this, I'm actually going to make a new file within the quick start. And we'll just call this our custom operator. And this is going to change over the life cycle of this whole project. And then I'll come over here and I'm just going to add it in up here, just so we can work with just JavaScript and don't have to be within these little script tags over here. I don't like being over there. So we'll just call this custom operator.js. So that should bring in whatever we write in here. And then to get started, I recommend, here, we'll actually just code through this so we don't have to do any copy and pasting. Well, I'll copy it actually. So I just took this from the documentation here. This is just our classic transparency peak operator. It's what I'm going to be starting with. You may have seen it before, but it's a very simple example of making your own custom operator. So what am I doing here? Really, I'm just setting up a basic object that has these methods that are implemented by the communicator.operator class. So you can see these are the methods that the operators will implement. So when I register this object with the operator manager, it'll know that these events correspond to be behaving like an operator. And so up here, we just have a constructor that's pulling in the viewer, and we're setting a null point or a part ID. And what we're doing is this is pretty similar. These couple lines here are pretty similar to what I just showed you in the selection manager. So we're setting up a pick configuration here. And this is just saying, what kind of geometry do we want to consider when we make this picking operation? Do we want to consider faces, lines, points, all of them? We're just saying, whatever we pick, give me whatever node ID is returned. We're performing that pick operation, so pick from point, and we're performing it at the position that the event is coming in at. So we have an on mouse down event. This is a mouse click event, and on that mouse click event, we can get the position. If you're ever curious what data you can get back from one of these operator events, you can go over to communicator.event, and these are the different kind of communicator events we have firing off. So this is an on down mouse event. If I go to mouse input event, and you can see the methods associated with that. And so I'm just getting the position, which will return the 2D position of where I clicked in the canvas, or on the screen, I should say. And then it's going to perform its picking operation and return a selection if it found one. So if I clicked off the model, selection would return either undefined or null. It wouldn't give you anything. But since I clicked on the model, it'll give you a selection of what was returned with this picking operation. We'll just make sure that it does have a valid selection type. It's not just a returning none. I guess that's what it would return, not null, but it would return this selection type none. And then we're going to get the node ID for the part that was selected with the picking operation, and we're just going to change its opacity and make it halfway transparent. And so that is while the mouse is down. If I release the mouse, we're just going to reset that transparency or opacity, and then we're going to set the part ID to null. So very basic custom operator. If I were to save this, we have our operator over here. But as I mentioned before, we need to actually register it with the operator manager. Right now, Communicator and the operator manager have no idea what's going on with this custom operator because we haven't told it to pay attention to it. So if we go back over to our main code, just under the Hoops web viewer here, we can get our, get our operator manager. I'll just save it into a variable so it's easier to access. Operator manager, okay. And then we'll say let custom operator equal new custom operator, and it takes the Hoops web viewer object as a, oh, I called this sample operator. Let's let's see. Yeah, and it just takes a hoops web viewer object in its constructor. So that should actually instantiate this custom operator, but still, Communicator still has no idea about it. So we're going to use the operator manager to return a operator handle. So we're going to say operator manager. Sorry, let me rename this. I didn't mean to opman. Operator manager dot register custom operator, and we're going to pass it our custom operator. So this will actually register this operator object with the operator manager, and it'll return a handle. It'll just be a number, just like we were seeing before, where those built-in operators had enumerations for their handles. This will return me some sort of number, probably like 10,000 or something, that serves as the handle to interact with this operator. So once we have the operator handle, it's registered with Hoops Communicator, but it's not actually on the operator stack yet. So let's go ahead and push that to the operator stack just like we would before. So operator manager.push op handle. So to recap, we're instantiating this operator that we made over here, registering it with Hoops Communicator. This makes it aware to the operator manager, and then we can use that operator manager to just push that operator onto the stack. So if I did this correctly, I should be able to refresh over here. And if I click down, it won't work because, one second. Did I get an error over here? Yes. All right. Sorry, one second. Seeing what I did here. Custom operator. Interesting. Custom operator. I think it's probably because I named that the same. Let's try that. No. Not sure why I'm having trouble with this right now. We got to get this working though. Custom operator. I guess in the meantime, are there any questions that I can answer while I'm trying to figure this out? Custom operator.
Chris, you need to push on custom op, right?
Oh,
you're pushing. You need to push custom op on.
No, you push the handle, but that helped me see. I'm pushing. I had that old name in there still. So if I do that, there we go. Okay.
Yeah. Okay. Perfect.
Thank you. So sorry about that. I had a typo in there. So now if I reset here, I'm pushing this operator object onto the custom or the operator manager, and then pushing it to the stack. And so now it has top priority. If I left click here, if I hold down, you can see it changes to transparency. I can kind of peek inside. And when I release, it goes back to opaque. I'm sure you've probably seen this custom operator before, but it's a good starting point for where I wanted to be. Let's say I wanted to add something else. I wanted to spice this operator up a little bit. We're using on mouse down, but we're only using the left click button. Actually, before I do that, I just want to demonstrate something. So you see when I do this transparency operator, I mentioned that it has top priority on the stack because we pushed it. It's the most recent. It's going to be the first to see that event. When I release, it actually gives me a selection event too, which is kind of an undesirable behavior in my opinion. And that's because that event is being propagated through the operator stack. We're not actually handling it all after we do the transparency peak here. And so that's why when I release and I do this on mouse up, that it's performing that selection, that on mouse up code that we went over earlier. And so if you wanted to handle this within the operator code, you could do so by just setting set handled on the event. So if I do this for both of these methods here, and I refresh, even though the transparency operator is the top of the stack and there's other operators active on the stack, I now am handling that event. I did just get an error over here though. Set handled. Oh, set handled. There we go. So now I'm handling that event. I'm not getting errors now, right? Okay. Yeah. Handling that event, and I'm not performing that selection now because even though there's other operators active on the stack, I'm basically intercepting this event on the first operator here and saying, okay, don't propagate this event down the stack. Don't let any other operators see it. They all get a signal saying, okay, don't implement our on mouse down or on mouse up functionality. And that gives us just the transparency peak here. If you see I hold down and I try to drag it around, I no longer have that navigate capability either because I'm intercepting this event. So I'm actually going to comment these out for now. And rather than do that, I'm going to manage the operator stack a little bit differently, just because I don't necessarily want to inhibit things like navigation. I want to be able to navigate around my model while I'm making this custom operator. So rather than stopping the event to prevent a selection, I'm just going to take the selection operator off the stack. So we can do that with the operator manager, remove, and then just provide it its operator ID. Operator ID dot select. So this will just remove the select operator from the operator manager in the operator stack. And that way I don't need to set up this event handling here. If I peek, I gotta update that. And if I do this transparency peek and move around, I can now navigate while also peeking. So that's a good example of how your operators can kind of interfere, especially when you're starting to make these custom operators. So two options there are either smartly manage your operator stack, keeping an eye out on how things are being prioritized and what gets handled. Or while you're making your custom operator code, if you don't want that event to propagate down the stack, you can just simply set handled over here. So yeah, that's a good sample of a common pitfall that you could run into. Anyway, so you see we have an on mouse down event here, but we're only really listening to any mouse click. So if I do this with the middle mouse wheel button or the left or the right, all of them are giving me this transparency peak. So let's start mapping some specific functionality to specific buttons. So if I come in here, what we're going to do is create the ability to just remove an item. So say I wanted to look underneath this and peek into one of these internal items. Let's just say I want to remove the visibility of that if I center click or mouse wheel click. Well, that's easy. We can just come down here into our event, and we can set up a little switch statement that says event.getButton. So from the event, you can figure out what button was clicked. We'll say case communicator.button button.left. And so if we have a left click button, we'll just keep the same functionality there. Then we'll make another case that says if we have button.middle, if we do that, we will hide the part instead. So the reason I put the switch statement within the picking operation is because for either of these two, we're going to want to pick the best node that we're hovering over. Model, and then set nodes visibility. So very similar to set nodes opacity, it just, you give it a node ID or an array of node IDs. In this case, we only have one. And then we'll set a Boolean to say true or false. So we'll say we want the visibility off if we select with this middle button here. And we'll just put it default down here. Quick little message, no mapping. Okay, so let's see if this worked. Reset, transparency operator with the left click is working. And if I hit with the middle mouse, I can now remove elements just like that. Take a quick peek with this transparency operator, etc. So I can remove all of these. I can get it back with this context menu that's a part of the default UI. But let's say we didn't have that context menu there, and we wanted to get our parts back. So I've deleted a bunch of parts. Say I didn't have access to this reset model or show all over here. We want to put it in the operator somehow. Well, let's say we wanted to map that to a specific key. Let's say if we hit escape, we want our visibility to be reset for this model. Well, you can see here, we've only been working with mouse clicks right now on mouse down and mouse up, but you can also see there are these methods that can listen for keystrokes as well. You also have mouse wheel listeners. So depending on how you want your UI to kind of feel and play out, you can use these different methods. I'm just going to set up a keystroke. So if we hit escape, it'll bring back our visibility for our model. So I talked about this events page over here. These are mouse input events, but now we're going to have a key input event. I see that there's a get key code function here. And so I know this event is going to fire when I have some sort of keystroke from our keyboard. We'll just set up another switch statement to actually get what the key code is and then map specific functionality to that key code. So we'll take the event, say get key code. And then, yeah, you could set up a bunch of different keystrokes within here, which is why I use the switch here. But technically, you could just use a simple if for this example. I happen to know the escape code, or the code for the escape key is 27. I'll just put a little comment there saying that. And yeah, if we come in here, we'll just reset the whole visibility on the model. So we'll say this viewer model set nodes visibility, and we'll give it the root of the model, which is 0. The absolute root node, if you had no model in the scene, there's an absolute root node that represents your model. That's usually given as -2. The first model that will be added to your scene will usually have the ID of 0. For multiple models in the scene, you probably wouldn't want to hard code a 0 right here, but for the sake of this training, just keep in mind that represents the root node of this micro engine model. And then because visibility is inherited through the whole tree, I can just set it on this root node, say, give me all my nodes back. We'll set it to true, break out of this. And that should be all we need to really handle a key code. So all we're doing is, if we deleted some stuff up here, we're just going to reset the visibility down there. So let's try this again. We'll reset. We should have our operator on the stack. Got transparency, good. I can delete things. And now if I hit the escape key, everything comes back. It resets my visibility for the model. So that's kind of how you would map up certain keys, particular keys. So now, let's see. 1 second. There was one more thing I wanted to talk about before moving on. Just need to check. Okay. So now that we've kind of gotten the basics of setting up this custom operator, I want to show you the operator I'd like to build together off this kind of base code we've made. So if there's any questions about custom operators so far, in terms of either setting them up within the actual class of the operator or managing, instantiating and registering it with the operator manager, if there's any questions there, let me know now. If not, I'm going to get into a more complex custom operator. And just kind of to try to give you a good idea of what you could do with operators, and at the very least, it'll come out with a cool looking operator. So if you have questions, shoot them into the chat and I can answer them. If not, I will plow ahead and give you a look at this operator that we are going to make. Rename this. Okay. So if I reset this, hopefully this works. So what I wanted, I was thinking of an operator I could make that wouldn't be like boring, like just pick a color of this face. So I tried to make a interesting one, and one that I noticed that we didn't really have in terms of rendering modes. If you go through the rendering modes in here, you can see we have different rendering modes. They all look great. But we don't have any that really show the tessellation of our faces, which we do have on the side of our native graphics in Hoops Visualize. So I wanted to make an operator that would show me the tessellation of something. And so here we have our micro engine model. And if I click on, sorry. Uh-oh. This is a good gotcha as well. So you can see over in my operator, I'll get into the details here, but I'm interacting with the model class over here called create node. The reason I'm getting an error here is because right after the Hoops web viewer starts, I'm instantiating this operator, which makes a call to the model class. And essentially what this is telling me down here is that I'm making that call too early. The web viewer isn't set up enough. That model structure is not ready for me to start making calls to it. And that's why I just got an error there. So what I'm actually going to do is use the model structure ready callback to wait for the web viewer to be ready before I start instantiating this operator and pushing it onto the stack. So a little bit of an aside here, but we can say Hoops Web Viewer set callbacks, model structure ready. So if you ever need to know what callbacks you can set up in Hoops Communicator, you can come to the API reference, and there's a little callback map interface here. And these are all the callbacks that will be fired off in Hoops Communicator. The one I'm using right here is model structure ready, as you can see, triggered when the model structure has been loaded and is ready to be queried. So if I put this code simply within here, and then I'll get rid of it from out here. That all looks good. Okay. So now when I do this, it'll wait for the model structure callback to fire. I don't get an error over here, which is good. And now I can showcase my operator finally. So if I isolate this, if I'm clicking down now, you can see the opacity is sort of changing, but I'm also now creating this tessellated mesh over it and overlaying that to the original part. So what's happening when I click on one of these is I'm actually getting a copy of the whole mesh data, parsing through it, iterating through it, and creating polylines off of the vertices of that mesh data. And then I'm just overlaying it with the original part there. And so we'll go through and I'll show you kind of how you would do something like this. I also added a modifier that you could take out the whole, or make the whole original node transparent or invisible. That'll just give you a raw mesh like that. I kind of like the look of the mesh over the opaque geometry or semi-opaque geometry. But yeah, that's the goal we'll be shooting for, to get this mesh with a custom operator there. So let's take a look at what we need to do to get there. So I'm actually going to go back to where we were. So starting with where we were, we're going to be using the mouse on, mouse down event. So it's going to behave almost exactly like the transparency operator. We're just going to be doing a bit more work when we do the on, mouse down event. So we've got things for left and middle. Because we're going to be generating meshes based off selections, I don't want this to be generating meshes for button clicks I don't want. So from the start, actually, if we get a communicator button right button click, because I have my context menu on my right button, I'd like to keep it that way. I just don't want to perform a picking event at all if I have a right click. So I'm just going to say let button equal event dot get button. We'll take that, and then if button equals right, we're just going to return. So we'll just skip the rest of this logic. If we do that, we'll take button down here and switch this out. Okay, so now if I have a right click, this operator is just going to pass on anything done with the right button. And then we have our mappings for both left button and middle button down here. So what's the workflow of this? Well, it's similar to the transparency operator. So I'm hovering over a node with my mouse, and when I click it, I'm doing two things. One, I'm changing the transparency of the node that I'm clicking. So I'm making it somewhat more transparent. And then I'm also generating this mesh and visualizing that mesh on top of it. So if we were to just write in a little pseudocode of what we needed to do, on our left click, we need to change the transparency, and then generate a mesh. And then we're going to set the visibility on that mesh. Okay, so we actually have our transparency here. I'm going to change the value to give you the look I demoed earlier. We'll just make that 0.9. So just a little bit of transparency that you can see through, but it's not so bold that it's interfering with the polylines that we're going to draw over it. Then we need to generate a mesh, so that's going to be a big function. I'm going to just wait a second on that one, and then set the visibility of the mesh. So another problem we run into is, obviously, I can click this part many times. I don't want to generate a mesh every single time I click on that. So what I'm actually going to do is set up a little map that tells me if I've already generated a mesh for this part or not. So up top, I have a part ID. I'm also going to make an ID. I'm going to track the ID of this tessellated mesh that we're going to make. So I'm going to have mesh node IDs as well. And then I'm also going to make this map called isGenerated equals new map. And so what's going to happen is when I left click, I want to first check this map to see, does this part ID that I'm using to make this selection already have a node associated with it? So I'm just going to quickly peek into this map. If there's nothing in the map that shows I've generated a mesh, I'm going to go ahead and generate that mesh. Then that mesh is there in the viewer that I can just toggle its visibility on and off in the future. I don't need to spend the time to regenerate a mesh every time. So what does this code look like? Well, we're going to have this tessellated mesh node ID. We're going to get that back if we've made a mesh with that node ID. We haven't done any of the meshing code yet, and that's where we'll set this mesh node ID. So what you're seeing now you'll think, well, duh, it's going to return undefined. But I think you'll see the idea once we get a little bit more code in here. So we're just going to check this map. Say get, and then we have the part ID. So it's going to be a mapping from the part ID, the selection, to whatever its corresponding mesh is. So when no meshes are generated yet, this is just going to return in undefined. And so if it does return either undefined or null, we're going to go ahead and generate that mesh. So if this dot test mesh ID equals undefined or equals null, this is where we'll generate our mesh. And we'll get into that function in a bit. And then if not, if we already have a if we already have a mesh for this, all we want to do is toggle the visibility for that mesh then. I have too many of these. Okay. Okay, so what we will do is say oops webviewer.model dot set nodes visibility. This dot test mesh node ID true. And actually, we're going to want to do that regardless of whether we need to generate a mesh or not. So let's see. If we click the left button, we need to set the node opacity. In here, set that to true, set the node opacity there. Okay, I see. All right. So how do we get this this mesh? So let's go down here. We're actually going to make a separate function for it. And we're going to call this generate. Whoa, where did my cursor go? Generate mesh lines from faces. All right. So to do this, actually, we're going to pass it a node ID as well. So we have our part ID. We're doing our picking operation. Once we have that part ID, we're going to use that part ID to get us a copy of that mesh data. So let's go up here and call this with the part ID. Okay, so we're passing this part ID from the picking operation into this generate mesh lines from faces function. So we're getting a node ID. And as I mentioned, we want to get the mesh data from this node ID. So just for convenience, I'm going to set up some variables like model. We're going to make a new mesh data object. And you'll see where this comes in a bit. Okay. And then this is the API I'm referring to get the mesh data. So if you go over to the model class, actually I'll do it through here. Communicator.model. You can see there is a function called get node mesh data. It takes a node ID and gives you a copy of this mesh data back. So let's go ahead and call that. Excuse me. This part ID, or sorry, node ID. I guess you could also use the object, but we'll do this. And so that's going to return a promise. So it's going to take a little bit of time to make this mesh data copy. And when we get that value back, we're going to have mesh data copy, and then we can do something with that data. So I'm going to put that all within this then statement. If I can get this working. All right. So what is mesh data copy? Mesh data copy is a series of elements that consists of face, lines, points, basically everything that makes up the mesh that I selected. The one that I selected, you can see over here, it has these lines on there. It has all these faces, but it doesn't have individual lines for every single edge of the triangles making up it. So what I want to do is I want to query the faces and get the vertex data that's making up these faces. So in order to do that, I can access the faces property of this mesh data copy. So let faces equal mesh data copy. It'd be nice if I spelled that right. Mesh data copy, top faces. So that'll give me faces. And then that gives you this element group of faces, which actually has an iterator. Actually, I'm not going to use this iterator. I'm going to use the element iterator. So for each element, there's going to be a number of elements that are returned that make up this node ID. So you have your whole part. That part has individual elements of these meshes that make up what consists of that part. So you can have more than one element count. So the main thing to focus on here is I'm just going to iterate over all of the elements for this return to node ID. So for 0 to element count, for each of these, I am going to get that element, let element equal faces dot element I. So I'm getting a specific element. And then I also want to check to make sure that that element has vertex data associated with it. Sometimes you might get an element that has no vertices, say if it's like a placeholder type element. I'm not actually sure why it would return 0, but I've seen it in the past. So I'm just going to put a little data guard in here that just says if element.vertex count. Let's click on element too. So element, you can see there's a property there called vertex count, and then a method called iterate. So if the vertex count equals 0, I just want to go on to the next element. Don't do any of this other logic. And then we're going to get the iterator for this element. Iterate, boom. All right. And so what that iterator is going to give you is an iterator that goes through each vertex of this element group. So it's going to go give me the first vertex, second, third. And because this is made up of triangles, we want to gather 3 points of data. So 3 vertices. And then we also want to grab that first vertice once again, because that's going to complete the triangle. If you can imagine 3 points of a triangle, if I draw a line from the first to the second, second to the third, those are 3 points, but I don't know where to go from there. So I want one more polyline that goes from the third back to the first. And so I have a little loop here. I won't spend time coding it up, but what I'm doing, my end goal is I want to make this mesh data. So I'm trying to make a mesh. And to make a mesh, I need to provide mesh data saying, this is what makes up the mesh. These are my vertices for a line, for example. So in this case, I want to visualize everything with just lines. So I'm going to be drawing lines between all the vertices that make up these faces. So I have this array of vertices. I'm just going to use the iterator to give me the next vertex in this element group. And then I'm going to spread that vertex into this vertices array. This needs to be flattened because we can't pass in an array of vectors into this add polyline function. This needs to just be a flat set of vertices. So what I'm doing here is I'm gathering each 3 set of vertices, pushing them into this vertices array, and then I'm pushing back this first position again to complete that triangle. And once I've completed that triangle, I actually add that triangle to this mesh. And so I go through this loop until the iterator says the next element is undefined. So this will go through all of the vertices that are part of this element group. Once that element is done, it'll go on to the next element, and that will go through for the whole node ID that I selected. So that should build the actual vertex data up. Now that we have that vertex data, how do we instantiate a mesh? So we're going to use the create mesh function. So if you look over in the model class, there's this create mesh. So we have this mesh data object that we need to pass to this mesh function and configuration, which I am not going to use. But if we look at the mesh data object, that's what we were adding to in this whole process. So we're gathering our points, and then we're just calling this add polyline function for this mesh data. And all that add polyline function does is take in an array of numbers, and it's just going to connect the dots essentially. So I'm just doing that over and over again to build my data. So now that I have my mesh data, I can call this create mesh function. So and that's going to return a mesh ID. So we'll call test mesh ID equals model dot create mesh, and we're going to pass our mesh data object to that from up here, which we populated with our polylines. So that will return a mesh ID. That will give us the mesh, the actual mesh, but that's not an instance of the mesh. You actually need to instantiate the mesh into your scene in order to have it render in a part of the actual hierarchy. So in order to do that, we need to use this function right underneath called create mesh instance. We need to pass in a mesh instance data object into that. So if we look at the constructor for this guy, you can see we're referencing the mesh ID of what this instance is going to be based off. So we created the mesh here. We got a mesh ID or tessellation mesh ID back, and we're going to use that ID to this mesh instance data, and it's going to build this instance based off that mesh data, and then you can set specific instance behaviors of this data from this object. So let mesh instance data equals new communicator dot mesh instance data, and we're going to pass it the test mesh ID. Let's see what else we have over here. A matrix. I'm going to pass on that for now. I'm going to return to that though. We can call it or give it an instance name. We'll just call this node node ID mesh. Yeah, so it'll give us whatever the original node ID was, and then we'll call it the mesh. What else do we have over here? Instance name, face color, line color. I'm going to set the line color to be black. So let's see, null, new communicator dot color dot black. And I think that's all I really want from that one. So that's going to set up the mesh instance data. Now I can actually instantiate this into the scene with create mesh instance. And you can see create mesh instance is going to return a node ID. That is the node ID that I am going to store in my map. And so this will say, I've created a mesh instance for this selected part. Now in the future, if I click on this part, just toggle the visibility of this node ID. Don't generate a mesh again. So we'll say this dot test mesh node ID equals, this is a promise, so we're gonna wait for it. I'll make this an async function. Is that where I need that? Yeah. We're gonna wait for the value to return model dot create mesh instance with our mesh instance data. What else do we have here? Parent node ID. So I'm going to put that as null right now, but we will revisit that as well. And then you can see we can make it reset from, or prevent from resetting. I'm going to make this true, and I'll show you why in a bit. And then is out of hierarchy. We'll keep it in our hierarchy because we want it to behave to certain APIs, such as toggling visibility and stuff. And then last but not least, we are going to set this in the isGenerated map. All right. So I forgot an await here. I'm using await just to make things simpler and more readable here. It's probably not the most efficient, but for the time being in this training, I think it'll work. So that's how we would generate the mesh. A little bit of a tangent there, I know. So back to our operator code. If we right or left click, we don't have an ID for it, we're going to generate that node. Because we're calling some functions down here, I want to wait for this to finish before I end up toggling the visibility of it. So I'm actually going to turn this into a promise and wait for it. And that'll ensure that the mesh is created before I start trying to like toggle visibility or do anything else with a node ID that isn't actually created yet. So I will take this. I am going to resolve this. And what have I missed here? This goes there. I think I need just one more of these. Okay. So that turned that into a promise. Now I can wait for it to finish. Let's see. What happens? I think that's all I need right now. Yeah, let's see what happens if I try to run this. We'll probably run into something, but we can work through it. Yeah. Oh, I need to put that in a. There we go. Okay. So it's halfway working. Node is not defined. Where is that? Oh, okay. So this needs to read node ID, not node. Probably have a few other little guys like this. Yep. Get node. Lots of typos. I don't want mesh data for my nodes personally. Okay, there we go. So now we're getting the mesh there, but you can see it's not exactly working. So I talked about some of these parent nodes in this matrix down here. We have a few options for handling this. We can either set it to the parent node of the node ID that I selected, and that will make sure that the whole matrix hierarchy is copied. And that way, when it gets down to this node ID, it has all the transforms to know where to put this node. Right now, we passed null in there for a matrix, and we also passed null for a parent ID. So these are just being instantiated at 0, 0, basically, when I create these. In order to capture that spot, I'm going to actually come down here, and I'm going to get the net matrix for the node ID I have. So I'll just say, give me the net matrix, and then I'm going to pass that matrix in when I make my mesh data. So that's going to instantiate this instance at that matrix location. So now if I reset, I click on here, that one looks good. That one looks good. You can see we haven't set up toggling off the visibility, but we're getting our mesh. Last but not least, we want to come in here when we release the mouse up, and because we're running low on time, I'm just going to copy this over and talk about it. It's fairly straightforward. So all we're doing is resetting the operations that we did on mouse down. So we're going to reset the opacity back to full. We're going to set the node visibility for the mesh off. We have that node ID now that we can do that. And we're just going to reset the part ID back to being visible if we did hide it. So now if I save this and reset, when I click up, the mesh should, well, here we go again. Keep doing that. There we go. So now when I click up, the operator disappears and we get our opacity. If we were to isolate this, you can now see a nice little mesh on top. You can see it's somewhat transparent. You can see the tessellation behind it a little bit. And yeah, it gives you a nice looking mesh for what's actually representing this face. You can see all these individual triangles if you zoom in and really see what's comprising the face. There was just one last thing I wanted to try to cover. And again, I think I'm just gonna copy it over. And this is just using key modifiers. Let's see. I think this is where I want to put this. Okay, so this is basically the same code I just had, a little bit different. I wanted to point out this. So what I've done here is I've added a key modifier that says if I'm holding control down or command down, I actually don't want to use opacity. I just want the original part to disappear. Else, if I don't have one of those modifiers down, just make it a little bit opaque again. So if I reset this, and now I have this logic in here that's looking to see if I have something held down. So if I hold command down, you can see it just toggles the visibility of the original part. It doesn't make it opaque. If I release command and I click on it, you can see it keeps that opacity. And so that's just a quick example, easy example of how you can add modifiers to your operators as well by just adding in keystrokes and then using logic to check the event to say, okay, what came with this event? We've got a button. Do we have any key modifiers? You can use it for like shift or command or control. So you have different modifiers that you can also add in and enhance the capability of, say, just a simple click.